Welcome to Service Protection and Control for Apartments and Similar Buildings. Within this module, we're going to be looking at two different objectives. First, we're going to look at different types of service equipment layouts that we can use. Then we'll look at the grounding and bonding requirements of apartment buildings and compare those to what we normally would see inside a single dwelling. When we are dealing with multifamily services, we do have a couple of options on what kind of service that we can install. We have the choice of doing either a cold sequence metering or a hot sequence metering, depending on the application that we have. When it comes to doing a service on something like a row house, which would include duplexes, triplexes, and fourplexes, there are a few rules that we need to know. Rule 6402 sub-rule 2 states that we can locate our meters on the load side or the line side of the service box. But what we need to know is what is the ampacity rating of each consumer service and what is the voltage rating of the service itself. We need to make sure that we are less than 300 volts line to line, and each consumer service cannot be more than 200 amps. This makes hot sequence metering suitable for things like single family dwellings, duplexes, triplexes, and fourplexes. But there are a few more rules that we need to know about. Rule 6102 states that we can only have one supply service, so the service coming in from the utility per building. There are some exceptions with that, so make sure you read through that rule. Rule 6104 states that we are allowed to have multiple meter bases on the same building, but they need to be ganged together. In order to do this, we'd use what's called a multiple lug meter mounting device. This allows us to gang up to 4 meter bases into one single unit. The thing with this is that we need to make sure that we understand that as soon as we do this, each individual meter is considered to be the consumer service for that suite. So when we're talking about that 200 amp rule and 300 volt rule for our hot sequence metering, this is the service that we're talking about. We're not talking about the supply service because that's likely going to be more than 200 amps. But our individual suite services, our consumer services, cannot exceed 200 amps. These multiple meters are also considered to be busways or splitters. So there's a couple of rules we need to be aware of from Section 12. Section 12 2000 states that they must be approved for use and location. Section 12-2020 states that we cannot use it for a pull box, so we cannot have any other circuitry inside this particular service box. For our larger commercial services, for any applications where we have more than 4 consumer services, we could use cold sequence metering instead. This would be applicable for any services that are over 200 amps, and then we can take our services and then subdivide them into each individual unit. We also have a choice in this case to either have one single meter monitoring the whole building, or we could have individual meters per suite. Typically, if we're going to have one meter base on a service like this, it's likely that meter base is going to be over 200 amps. And if it is, we must do something called a current transformer, or a CT. This is also called an equipment transformer, so be aware of both those terms. Rule 6404 sub-rule 3 states that if we have a single meter in a building that is more than 200 amps, we need to make sure that we have a current transformer placed ahead of the meter base. Our line conductors will go from our service box into our CT cabinet and then continue on to our feeders to feed our individual suites. Then the meter base is mounted on top of the CT cabinet, where we will have our current transformers inside the box, and we will be required to use 2 10-gauge conductors per CT to go from our CT cabinet up into our meter base for the utility to connect to. And we need to make sure those 10-gauge conductors are at least 2 meters long to facilitate that connection. Now we can take a closer look at what is actually inside a CT cabinet, or what's inside an equipment transformer. The current transformer's job is to monitor the line current, and then they step down that current by a specified ratio. The meter readings are then multiplied by that CT ratio. We must make sure that according to Rule 6404 sub-rule D, that the CTs are properly secured to the enclosure. The reason that we use current transformers is they are a safety measure that's meant to limit the exposure of any electrical energy at the meter base. So instead of dealing with a 1200 amp service at the meter base, now we can step that down to a much safer level. If you look at the current transformer itself, you can see 2 screws on the very top of the transformer, and this is where we would be running our number 10 gauge conductor from that location up into our meter base for the connection by the supply authority. The reason that we use the number 10 gauge conductor is this will minimize any voltage drop between my CT cabinet and my meter base so we get more accurate readings. If we were to do individual meters for each suite, we need to look at Rule 6406. This states that where individual metering is required for feeders for each suite, it will have its own dedicated meter and disconnect. So we can either use individual meters or we can use multi-service equipment to do this. Rule 6214 states that each service box needs to be properly and permanently labeled to identify what it is controlling. This type of service would reflect any other type of service that we have for an individual unit, such as a house. Rule 6408 states that service equipment shall be grouped together if possible, so we need to make sure that everything is put as cleanly and nicely together in the same location if we can. Rule 6410 states that meter locations are going to be determined by the supply authority, so we need to get approval by the supply authority to what we want to do with our metering layouts. So it's a good idea to have a good picture about how it is all going to work together and what the final product is going to look like. Keep in mind this is also going to affect the meter heights. So we will not be able to put our meters too high because that will affect the meter readers' jobs. Regardless of how we do it, we must make sure that the service boxes are clearly identified. Rule 6202 gives us the option of using multi-service equipment, and the multi-service equipment will have the disconnects and the meter sockets for each individual suites. Here is an example of just this type of installation where we do have the meter bases and the disconnects per suite right beside them. You'll also notice that each disconnect does have a label below it identifying which suite it controls. A nice part about using equipment like this is it makes our equipment rooms look so much cleaner and nicer to work with. It also has the advantage of conserving space. Now that we have looked at the different ways that we can install our service equipment, we're going to review the rules on bonding and grounding of our service equipment. First of all, when it comes to grounding a service, the grounding must be done in the service box. Our grounding conductor shall be either a number 6 copper or number 4 aluminum wire. Now this is exactly the same as we had with single-family dwellings. Our neutral conductor is going to be connected to our grounding conductor at the same place. So we will facilitate a connection between a neutral and our grounding conductor inside our service box as well. This means that our service box also needs to have the bonding jumper. The bonding jumper is what's going to connect my grounding conductor into the box itself. So any of my non-current carrying metal parts are going to be connected into my grounding system through the bonding jumper. In order to facilitate this, we can use a manufacturer's screw or strap, or if we need to, we can use table 16 and provide our own bonding jumper if no strap or screw is present. Within our service, we must also make sure that we are properly bounding our service raceways. So just as with our single-family dwellings, we cannot rely on lock nuts alone to properly bond our service raceways. So we must use grounding bushings or bonding bushings to do the job as well. The service raceway bond should be sized according to table 16, and that needs to be put in place inside the service box as well. Since I have my grounding happening inside my service box, this means that everything after my service box is going to be treated as a branch circuit and will follow the normal bonding rules of any branch circuit. Any type of non-electrical equipment within my building also needs to be bonded to ground by a number 6 copper conductor, so this would include my metal water pipes or my gas lines. These must also be done inside the service box. For our bonding requirements to anything other than the service raceways, we can do this through our metal raceways or our bonding conductors, and we can use standard fittings and lock nuts in order to facilitate the bond connection. The bond must be continuous to all non-current carrying metal parts. So anything that is metal within our service or our installation must be connected to the bonding conductors. If we are going to be running a bonding conductor inside a raceway, we can use the metal raceway itself as a bonding conductor. However, if we're using something like a PVC raceway where we need to install our own bonding conductor, we will be referencing back to table 16. One very important rule is 10.2.10 subrule D, which states that no other connection to the grounded conductor is allowed on either the load or the line side of the bonding jumper. So where we have our bonding jumper inside our service box, We cannot have a connection anywhere else between my bonding and my neutral. This means that for my apartment buildings, I need to check every single suite panel as well as every single suite disconnect to make sure that if there is any bonding screws in any of those devices, that they are removed. The problem that we can have if we don't remove these screws is if I have any current running on my neutral conductor, that current can also use my bonding pathway to carry that current, which means that I could be possibly making all the non-current carrying metal parts live, which would create a dangerous situation. This is why we want to make sure that we are fully isolating my neutral from any other bonding point except for inside our service box. When we take a closer look at Table 16, we see that Table 16 is based on either the amperage rating or setting of the overcurrent device protecting the conductors or the equipment, or it is based on the allowable ampacity of the largest ungrounded conductor or group of conductors. So if I have multiple conductors running in the same raceway, I would use the allowable ampacity of the largest one against this table. For example, if I had a conductor that was rated at 85 amps, I would use the 100 amp row within this table to see that I need to have at least a number 8 copper conductor or a number 6 aluminum conductor for my bonding conductors. If I'm using cabling, I am required to use the integral bonding conductor that is inside that cabling in order to facilitate any of my bonding. You have reached the end of this lesson, so make sure you are reviewing your module as well as the code rules and the video, and if you have any questions, please reach out to me. When you're ready, continue on to the next video.